Hello everyone, my name is Naveen Kumar. Today my topic is about aerospace propulsion, which is also called rocket propulsion. And the topic for the concept video is about the silent features of a liquid propellant rocket engines. And coming to the introduction, liquid propellant systems carry the propellants in the tanks and the external combustion chamber. The most of these engines use a liquid oxidizer and liquid fuel, which is transferred from their respective tanks by pumps. The pumps raise the pressure above operating pressure of the engine. The propellants are injected into the engine in a manner that assures automation and rapid mixing. Here, here in the liquid propellant, here in the liquid propellant rocket engines, generally the propellant is used which is in the form of liquid, whereas in compared with the solid propellant rocket engines, the propellant it is in the form of solid. Here in the liquid propellant rocket engines, the fuel which is the fuel and oxidizer which is pumped into the combustion chamber with the help of pumps, and the pumps are generally like turbo pumps and centrifugal pumps, whereas in the solid propellants there is no requirement of pumps. This is in the basic principle of a liquid propellant engines, whereas the liquid and oxidizer, liquid propellant and oxidizer, which are coming from the tanks, respective tanks, and they consisting of pumps, and the pumps are used to transfer the fluid from a lower energy to the higher energy. So it will atomize the fuel and the air oxidizer, and it will the igniters will be provided, and those igniters will ignite the fuel and oxidizer, and the heat is produced, and this heat is pro, this heat which is produced in the combustion chamber will passes through the nozzle, and the rocket may get accelerated. And the my topic is about the liquid propellant silent features. And here there are many rocket motors which are solid rocket motors, liquid rocket motors, hybrid propulsion like electrical, solar propulsions, uh, in chemicals, and nuclear propulsion. Here my topic is about the silent features of a liquid propellant rocket engines. Why these are used, what are the special features are used in the place of other rocket engines. So I want to discuss some points which are the features of liquid propellant engines, whereas compared with the solid propellant engines. Liquid propellant engines have certain features to make them preferable solid in more applications. Here we are comparing with the solid propellant. It is comes and generally the features include it has high attainable effective exhaust velocities. In the solid in the liquid propellant, attainable effective velocities are more where we compared with the solid propellant engines in rocket engines. Here generally there will be more exhaust velocities uh, in the liquid propellant engines. It burns fuel. It has high specific impulse, so though which will ignite the fuel very speedily, and the exhaust which is coming is very higher in compared with the solid rocket motors, and higher mass fractions propellant divided by the inert mass components. Here the high mass ratios means high mass ratios means it is the ratio of mass flow rate to the final to the mass flow rate of initial. So the mass flow rate of initially is more, so it is here the main aim is to higher mass ratios. Control of operating level is flight, throttleability, and sometimes including stop and restart of capability and emergency shutdown. As we all know that solid rocket motors does not have any throttleability, like it will burns continuously and produces thrust continuously, and there is less like there is no chance of stopping on the solid rocket motors. Whereas in the liquid rocket motors, we can stop the vehicle by throttleability, by turning off the valve of the liquid propellant and oxidizer. We can stop the and control the flight operations. So this is another benefit and another feature of the liquid propellant motors. And the liquid propellant engines have high specific impulse as compared with the other engines like a solid propellant engines. Here, as we discussed that liquid propellant have high specific impulse when we compared with the solid propellant engine. It has in around 400 of seconds, like it has a high specific impulse where compared with the solid propellant engine will burning rate is more in this solid liquid propellant engines, and we compare with the solid propellant engine, which will cause producing of high speed, high velocities. And these liquid propellant engines has high ranges than other engines. Uh, like when we compare with the solid propellant rocket engines, there will be less flight, like small. It is used for low ranges, like it is not capable to fly more ranges, like more uh, distances. Whereas these liquid propellants are used for the higher ranges. It has capability to go high ranges. Liquid propellants will have more stability due to the damping effects and fuel. It will resist the vibrations and by the engines. As liquid propellants are really more stable compared with other propellants in terms of vibrations which are caused by the engines due to this damping effects, as we know. And these engines will take off easily when we compare to the solid because it burns easily. Uh, there is this point is not up to the limit, but I want to tell that like liquid propellants will ignite easily when we compare with the due to this throttling capability, like due to the high specific impulse they can burn easily, and that burning time, like the takeoff time will be much lesser when we compare with the solid propellant, because it has to burn, and as we all know that burning of a solid fuels which takes time. uh, there is no issues while taking take off of a flight, whereas in compared with the solid propellants, it is liquid propellants will consumes less time and takes less time to fly, to fly to get take off. And I want to tell about the schematic diagram. As this is the fuel and this is the oxidizer, and the fuel which is connected to one pump, and other oxidizer is coming connected to other pump, uh, and here we have combustion chamber, and these two are connected to with the pumps, and which are connected to the combustion chamber, and here the throat section, and here the nozzle, as it is acts as a convergent nozzle. It is a throat and it is the divergent nozzle. As we all know that in the CD nozzle, if the area increases, the velocity of the flow get increased in the divergent nozzle, and here the flow get choked, and here the point where the maximum mass flow rate will be present, and here the higher temperatures are present in the convergent entry of this convergent entry of the nozzle, and here the velocities are existing. V is the exhaust velocity or exit velocity, and P is the exhaust pressure, and P naught is the stagnation pressure, and V is the velocity. M naught rho is equals to is the M dot is the mass flow rate, and P is the pressure, and A is the area. And thank you.